then you're going to also determine the resting values of all of those too. So kind of just like we did in for the class part, we had that table and you did the resting versus the maximal. So those are, I'll show you how to do that right now. And then you're going to write out this fold difference. Okay, so to find the fold increase in something, you're just going to take the maximal value divided by the resting value, right? And that'll give you a number. Okay, so if your VO2 went from 3.5 at rest up to 35, right? You just take 35 divided by 3.5. That's 10. That's a 10-fold increase, right? So that's all it is. Okay, so you're going to do that for each of these variables, okay? And then we're going to talk about you're going to look at those secondary criteria. Okay, so secondary criteria to determine whether or not you reached a true max during the test are the RER getting above 1.1. Okay, so did your RER get above 1.1? Okay, that's just yes or no. Heart rate. Did your max heart rate get to get within 10 beats per minute of your age predicted max? Okay, so for most of you, you're right around 21, 22, somewhere around there, right? 20, whatever it is. So just do 220 minus your age, and then did your heart rate get within 10 beats per minute of that number? Okay, so that's the criteria. For the RPE, I think we've mostly been using the 10-point scale, right? For most people, let's just stick with that, and then what that means is it needs to get at least up to an 8 on the RPE. And so I'll show you where to find that on the Excel sheet, but it's going to be down on the bottom. It doesn't go into one of the columns; it goes down on the bottom. Okay. And then you're going to use that predicted VO2 max over there. Just look at how that compared to your measure. Okay. And then you're going to use the group VO2 max in liters per minute. Graph that versus body weight. So this is from the group data that we have on the Google sheet thing. Right? So just one graph of body weight versus VO2 max in liters per minute. Okay. And then another graph of mLs per kg VO2 max and body weight. Okay. And then you're just going to think about what those two graphs mean. Okay. And so again, you're going to find that R squared value of those two relationships, and then just interpret kind of what that's telling you. Okay. And then we're going to do another graph of predicted VO2 max versus measured. Okay. And so if this was a R squared of like 0.9, that would tell us that it's a really good predictor of VO2 max, right? That spreadsheet is over there. Right? If it's not so good, then it might, So that's what you're interpreting. You're just interpreting how well that equation predicts the actual measured VO2 max. Right? And so then this is something you want to just think about, right? If it didn't reach a true max based on those secondary criteria, why not? Okay, and even if you did, still need to answer that question. Why might somebody not go all the way to their max? Okay, so just think about some other issues that might stop them before their cardiorespiratory system is truly at its max. Okay, so that's just kind of overview on that. Any questions on those questions? So you're gonna complete these in a separate Word document. You've got I think it's 3 graphs there you're gonna make, right? You're gonna put all that together. This is a 50-point lab. The other ones are 25-point. So you're putting all that together and uploading that to Canvas. Okay. By class time next week. Okay? Any questions about any of those? I'll show you how to work with your Excel sheet here. Okay, so after you do your test, you'll get a sheet like this. This is John Marks from last week. Okay, you've got your height and weight up here, your age, name, all of that stuff, the date, and then these are the variables that we have. Okay, and so this tells you what each column means. Right, so we got time, and you guys have already dealt with this already. So yeah, we've gone through that with the energy expenditure data, so you should know what all this stuff looks like. If it's a treadmill, you have speed and grade. If it's on the bike, it'll say work rate or work something, right? You'll see wattage. Okay, so by these columns, you can tell where the resting period is. Okay, if everything is 0 over here, that means that's the rest period, right? So when you want to find your resting values, then you want to get the average of that. Okay, so average VO2 during rest, you want to use this right here, get your average. That's going to be down here. Okay, so that's the average that you're going to use for the resting one, because you're going to compare resting and maximal for all these different values, right? So just find your average. So for the rest, don't just use one cell. Use the average. Okay, and then so you're going to do that for all of the variables there. And I think I've got all of the ones here you need. Yeah, this RR is the respiratory rate one. It's just breaths per minute, right? How frequently are they breathing? Heart rate, ventilation, VCO2, and we have VO2 in liters per minute and mLs per kg. Okay, so you're going to calculate all of your resting values, okay, and then you're going to go down and find where you maxed out. Okay, so this was all the warm-up, right? So 6 and 0 for him was all warm-up, and then all of a sudden the speed jumped up to 7.3, and then the grade started going up 1% per minute, right? So we can see where we're at in the test, went all the way up to 14, right? So we went right into 14, so 7.3 and 14. And so that's where we're going to want to start looking for max sometime around that when we saw the intensity stop going up. Right? So the way we're going to do that is we're looking for the two highest consecutive values. Okay, so we'll start with the liters per minute one. And so the way, this is 15-second data. To really determine a good max, you want to use 30 seconds of data. Okay, I could have the computer do 30-second outputs instead of 15, but then it chooses which two 15-second ones to do. I'd rather be able to pick the two 15-second ones that I like, okay? Because the computer might choose these two, or it's just in the way that the time works, right? It just averages 30 seconds, whereas obviously this one is higher than the other one, so I would choose those two for my 30 seconds, right? So we need 30 seconds of data to get a max, okay? When we did it in class, I didn't go into this detail, so that I want you to know that detail for the lab, okay? So you're always going to have a high one and a low one, a high one and a low one, and that's why you need more than 15 seconds of data to get max, okay? So we want to find the two highest consecutive that give us the highest average, okay? So this one's the highest for sure, the 4.86. But is that one really going to give us the highest average? Because the ones next to it are pretty low. So let's look at that. 4.67 is our average there. Or are we going to get a higher one if we go like these two 4.6s? No, that gives us 4.64. Right. So yeah. So we're going to go with these two. Right? Because that's going to be our highest. 4.67 is going to be our average. And then it's not going to change when you go over to the mLs per kg. It's still the same thing. It's just divided by its weight. Right. So we're going to use these two, so that average is 59.6. 59.6 right there, right? So that'll be his average, or sorry, his max in mLs per kg. And then with the other ones, we don't really need to do the average of the two, okay? I don't remember what this D column was. What is it? Okay, that's METs. That's not one you have to do. We got CO2, ventilation, RER. So let's look at all of those. Okay, so this one's CO2, again, yeah, you can do the same thing there. So you can just pick the highest one if you want. It's probably still best to do the average of the two highest with that one too, because it's kind of the same principle. So yeah, why don't you just do the same thing? And the only one you won't do that on is the heart rate, because the heart rate is just what it is. It's not like with the breathing variables, we do this because you might not get the same number of breaths every 15 seconds, right? But with the heart rate one, it's just that's what his heart rate was at that time. Yeah.
Do you take like the highest regardless of if they're in the same row as when it's
No. So start with the VO2 stuff, and then just go over and use all of those in the same row. Yeah, don't choose different ones, except for heart rate. Heart rate we can go a little bit up. We can go to some of the higher ones. So his heart rate got to 197 here. I would take that for sure, because that was definitely his heart rate. Right? He actually was at max for a while. Right? He pretty much plateaued at the end. This is pretty much the same. So his VO2 didn't go up, but his heart rate was still going up. So we're going to take that 197 even though it was after, but we don't want to take that RER after VO2 max. Okay, because his RER with these two was 121, 124, right? So average there would be 1.23. But then if we look at afterwards, like we get to 1.53, 1.59, we don't want to take those RER values. Those aren't accurate RER values, okay? So the easiest way to do it is just determine your two highest consecutive, and then do that same thing for all of these columns, except for heart rate. Heart rate, go ahead and find the highest one, even if it's a little bit afterwards. Yeah,
Based on the prediction, it's pretty accurate.
it's pretty close.
Yeah, I was, the average is 0.1 higher than.
Yeah, that's amazing. Yeah, it's really good. Yeah.
Yeah.
So, yeah, it was super good. Yeah, so that, so that's that. So then, for the RAR criteria, he meets that, right? He's above 1.1 for the